Hello students, welcome to my third lecture in plasma physics. Today I'm going to talk more about plasma. If you look here, that first slide, this is a kind of solid form. When you heat solid, it becomes liquid. Then if you heat more, then what happens? The molecules evaporate and becomes a gas, and then if you heat more, then it becomes plasma. So basically plasma is a fourth state of matter, and you can see how one can have the temperature variation, then you can get the plasma from solid to liquid, liquid to gas, and gas to plasma. uh, so how it differ with the ionized gas? So this is slide where you can see here the ionized gas, which is characterized by a mixture of neutrals and positive ions and electrons. Basically, for a gas in a thermal equilibrium, the Saha equation gives the expected amount of ionization. So we can calculate how much the gas is ionized using this equation that is well known, Saha equation, and this expression have own importance, where you can see Ni Nn is nearly equal to 2.4 into 10 to the power 21 T raised to the 3 by 2 Nii e to the power Ui kBt, where you can say this is the ionization energy. Ui is ionization energy of gas, T is absolute temperature in Kelvin gas, and where Ni, N and Ni I will talk in my next lecture, next slide. That Saha equation basically describes an equilibrium situation between ionization and that is recombination rate, that recombination between ions and electrons. For example, if I take the previously what I said, if our Ni, if it goes here, then Ni is becomes a square, and N goes here. So here you can see Nn. So our expression becomes Ni square nearly equal to 2.4 into 10 to the power 21 and T 3 by 2 e to the power Ui kBt, where T is the gas temperature I said in Kelvin, capital K is Boltzmann constant, and where Ui is the ionization energy of the gas, where that Ni, Nn, and that is the simple the density of gases of ions, or Nn means neutrals atoms, what we are talking here. Let's say take example. So Nn, suppose we have 3 into 10 to the power 25 per meter cube. Temperature is the room temperature, and ionization energy is 14.5 electron volt. So we know that both relation, that kV and cap is Boltzmann constant, and electron volt is nothing but the 1.6 and 10 to minus. If you put all things in expression, so that just Ni and that expression Nn A, and then again temperature, it becomes this relation, and finally if you put all values which I had talked earlier like this, if you can put, then final equation becomes this. So you can see here Ni divided by Nn is the order of 10 to the power 1 2 3, is a very, is like huge. what does mean by this 10 to the power of minus 1, 2, 3? Let's talk more. So, the ratio of the number density, which is atom per meter cube of an atom in energy state B to those in energy state of A, is given by using this expression. So, we can write this way. So, this is expression where G's are the statistical weight of each level, the number of state, that means the number of state of that energy, and we can write for hydrogen level, you can write Gn is 2n square, which is just the number of different spin. 2 I have taken, spin up, spin down, and this number of different spin and angular momentum state. So, you can have the energy En, and that questions again I am going to raise, why plasma exists in astronomical bodies with temperature of million of degree, but not on earth. So, answer for that question becomes here, as the temperature, this temperature is here, this temperature is to where, one is temperature here and one temperature is here, right. So, let us see when temperature is raised, so what happens? So, degree of ionization remains low, right, until Ui becomes few times kT, like 2 kT, 3 kT or 4 kT. Then what happens? The ratio becomes abruptly rises and the gas becomes in a plasma state. Suppose I increase more on temperature, right. So, what happen? It makes Nn less than Ni. This is something the cracks of this understanding. So, Nn becomes less than Ni, and therefore, the plasma becomes ionized. So, this is the reason that that is reason for plasma exists only in astronomical bodies with the temperature of million of degree, but not on the earth. So, how that we can have the conversion from ionized gas to the plasma? Simple, the ionized gas is not necessarily a plasma. It's very important point. An ionized gas can exhibit a collective behavior in the interaction among charged particle when long range force prevail over short range forces, and ionized gas could appear quasi neutrality if the charge density fluctuation are contained in a limited region of space. Further, a plasma is an ionized gas that present a collective behavior and is a quasi neutral. So, on the basis of other factor, finally you can look out here plasma which have both things. It is also ionized gas, it is also a collective behavior and also have a quasi neutrality. That is why we call it fourth state of matter. So, the matter in ordinary condition presents itself in three fundamental stages of aggregation, like solid, liquid and gas. These different states are characterized by different level of bonding among the molecules. In general, by increasing the temperature, it means what we are just equivalent to increasing the molecular kinetic energy. So, when we do this, the phase transition occurs, and therefore, you can look out that my first slide where I talk about if you increase the temperature from solid to liquid, liquid to gas, gas to the plasma. So, that is phase transition occur from solid to liquid, liquid to gas. If you increase further temperature, so therefore, increases the collision rate and then degree of ionization of the gas also increases. Therefore, you can have the plasma state, that is fourth state of the matter. The ionized gas could then become a plasma if the proper condition for density, temperature and characteristic length are met, and that is well known phenomena in plasma, that is a quasi neutrality and collective behavior both. The plasma state does not exhibit a different state of aggregation, but it is characterized by a different behavior when subject to the electromagnetic field. That effect Pandya sir will talk about what happens when electromagnetic field comes in plasma. So, always remember that electromagnetic field also characterize and gives a different behavior of plasma. For example, just for to complete my things, it has been said that 99% of matter in the universe is in plasma state. Few of I am giving example. If you look here, lightning, Earth ionosphere, auroras, Earth magnetosphere, radiation belt, interplanetary medium, solar wind, solar corona, stellar interiors, interstellar medium. These are few examples. Even though lab plasma such as glow discharge, arc, fluorescent lamp, neon signs, electrical spark, thermonuclear fusion experiment, these are few examples which you can make it in lab also. Even though for house homely like that, the flame, or other example like rocket exhaust, these are few list of example where we can say the plasma have own importance role. So, in my next lecture I will give you proof of temperature, why temperature is important. So, for that I will show you the expression using the distribution that is known as Maxwellian distribution. So, in next lecture I will talk about more how the concept of temperature evolve the plasma. Thanks.